Okay, now let's try to find the eigenvectors. So the eigenvalues earlier which I found was, as because of a small mistake, actually I just got a different answer. But as I have already solved this problem previously, whatever the eigenvalues I've got, let me just try to consider the same here because again, if I have to replace everything, the entire answer could change. Imagine the lambda 1 and lambda 2 values, whatever you have obtained as 1.06 into 10 power 10 and the previous values itself. Now let's try to find the eigenvectors. To find out the eigenvectors, you have to write this first. K minus, that is matrix of K minus lambda 1 into M into x1 equal to 0. K is nothing but the stiffness matrix. So that one, whichever you obtained it earlier itself, whichever we got it earlier, the same, this values itself, whatever we took it for the determinant, that is nothing but the values of K. So K minus 1.06 into 10 power 9 minus 0.2 into lambda. You are going to take the same terms, but that is going to be in the determinant. This is going to be in the determinant. This is going to be in a matrix. That's the only difference. So let me, whichever you got it earlier, the same thing only we are going to take. K minus lambda 1 into M. So that one, whatever we got it earlier, into x1. X1 is something, but you can try to take it as q2 q3, that is equal to 0. Now let's try to substitute the value of lambda 1. Once you try to substitute the value of lambda 1 as 1.06 into 10 power 10 here, in place of lambda, we are going to get the eigenvector, that is the first eigenvector. So once you are trying to substitute it here, so only this lambda 1 is going to be multiplied with 0.2, that's it. And here similarly you are going to substitute it everywhere. So let me just show for one value alone here. So let me just try to put it over here. So you can just see only this first value I'll try to show you. The other things you can try to do it by yourself. So 1.06 into 10 to the power of 9. So 1.06 into 10 to the power of 9 minus 0.2 into 1.06 into 10 to the power of 10. So let me just get the answer. So the answer is found to be 1.06 into 10 to the power of 9. As I told, whatever the earlier answer I've got, I'm just trying to do the same. So you're going to get that. So similarly, upon solving the other terms also, you're going to get this. So now we are going to do the matrix multiplication. Only multiply this first row with this first column. So because anyways both are nothing but going to be q2 q3 only. We don't need two equations. If you are getting any one equation, it's enough. Therefore minus 1.06 into 10 to the power of 9 q2 minus 1.06 into 10 to the power of 9 q3 equal to 0. So just try to send this 1.06 into 10 to the power of 9 to the other side into q3 to the other side. You're going to get it like this. Therefore trying to send this back to the left hand side, you're going to get minus 1.06 into 10 power 9 divided by 1.06 into 10 power 9. So all those gets cancelled. So finally you're going to get minus into q2 equal to q3, because entirely that's going to get cancelled. Minus q2 equal to q3, or q3 equal to minus 1 q2, or you can simply write q2. Therefore x1 is nothing but going to be q2 and minus q2. So q3, in place of q3 I'm going to write it as minus q2, and you see it has to be q2 and q3 in the form of a column, but here I'm going to write in the form of a row, and I'm going to write it as transpose. That is q2 q3. If you're writing it like this, that is q2 q3 in a column. If you're writing it like this, you're going to write it in the form of transpose. As you know, the transpose of a matrix, all that. And in place of q3 I'm going to write it as minus q2, because we have got it over here. Now the next thing what you have to do is x1 transpose m into x1 equal to 1. This is nothing but going to be the formula. Once you do this, the eigenvector first, the first eigenvector, you can find it off very easily. x1 transpose is nothing but the same thing, x1 transpose. So you're putting the transpose over here, you're going to get this only as x1 transpose, q2 and minus q2. And the value of m is nothing but only the mass, elemental mass matrix which we obtained at the beginning itself. At the beginning of the problem itself we have obtained. Let me just show you over here. So here, so let me just show you clearly. So I'm sorry. So let me just show that clearly for you. So here we have got the the global mass matrix 4112. After eliminating the first column and first row, the remaining ones are nothing but 4112, 0.05 into 4112. So let me just take only the remaining ones over here. So you have this mass matrix 4112. So let me just take that q2 q3 over here as well. So q2 and q3 as well. Okay, q2, and in place of q3 I'm going to write it as minus q2. That is nothing but equal to 1. So next let's try to multiply this first two matrices first, then with the result whatever you're getting, that you're going to multiply with this third matrix. So q2 into 4 q2, minus q2 into 1 is q2. Then q2 into 1 is q2, minus q2 into 2 is minus 2 q2. Similarly, q2 into, I think we have got the answer, I guess. So this is the answer. You can just check the order of the matrix always. So the order of this matrix is 2 cross 2, that is 2 rows and 2 columns. Similarly, for this it is 1 row and 2 columns, and for this it is 2 rows and 1 column. So therefore, whenever if you want to do matrix multiplication, the number of columns in one matrix must be equal to the number of rows in the other matrix. Similarly, the number of columns here must be equal to the number of rows over here. And let me try to multiply that. So we have just got this. The result of this is this matrix 4q2 minus q2, q2 minus 2q2 into q2, this one, the same thing. You're going to take it over here. Now cross multiplying that, you're going to get 4q2 minus q2 into q2 minus, because here you have that minus q2 into minus 2q2 into q2. So once upon doing that matrix multiplication, so let me try to expand that. That is q2, let me try to multiply it inside. 4q2 into q2 is 4q2 square minus q2 square minus q2 square, minus into plus, minus is plus, 2q2 into q2 is plus 2q2 square. So upon solving that, you will get 3q2 square plus q2 square. This one, 4q2 square minus q2 square is 3q2 square plus q2 square equal to 1, and finally q2 square is 1 by 4, which is 1 by 2. And substituting that here in place of q3 is minus q2. Therefore, you're going to get half and minus half. Half can be written as 0.5, and minus half can be written as minus 0.5. So once you try to substitute that, you're going to get 0.5 and minus 0.5 transpose. So that is how, so that is what is the x1 value. So using that only, you have to find out the mode shapes. Similarly, let's try to find out the finally the eigen vector x1 is can be written as 0.5 and minus 0.5 transpose. Understand that? Transpose. Okay. Now the second eigenvector, the same thing, you're going to take only the place of lambda 1, you're going to replace it with lambda 2. K minus lambda 2 m into x2 equal to 0. So this one we have already obtained, as I told in the beginning of the problem. If you go, you will get that. So you can refer the starting of the video, or the similar way. In place of lambda, you're going to replace with lambda 2. Lambda 2, the earlier value, whatever you have got. If you just try to substitute it over here and put it over in the calculators, you're going to get this answer. 1.5 to 10 power 6, all that. So here also similarly, just try to multiply this first row with this first column. 1.5 to 10 power 6 into q2 minus 7.57 to 10 power 6 into q3. So sending that to the other side and equating it to q3. That is, if you're sending this minus 7.57 into the other side, you're going to get plus 7.57 q3. If you're replacing only, if you're retaining only q3, sending this to the other side, you'll get 1.52 into 10 to the power of 6 divided by 7.57 into 10 to the power of 6 into q2. So 10 power 6 gets cancelled. 1.52 divided by 7.57 is 0.201 q2. That is nothing but equal to q3. Therefore, finally, the values of x2 is nothing but going to be q2, and in place of q3, 0.201 q2. Put it as transpose again. Therefore, the formula again is going to be the same. 0 x2 transpose m into x2 equal to 1. So let's try to go into the final page of this problem. So x2 is nothing but going to be q2 0.201 q2 4. That is m value is going to be this, and next this is nothing but x2 transpose. This is going to be m. This is going to be x2, but x2 transpose is going to be this one. You can just see clearly q2 and 0.201 q2 written in the form of a row matrix. Here it is written in the form of a column. That's it. So first multiply this first and second matrix, you're going to get the answer like this. Multiply this with this matrix, you're going to get it like this. So let's try to multiply this. 4 into q2 is 4q2 plus 1 into this is going to be this one. Next q2 into 1 is q2 plus q2 0.201 q2 into 2 is going to be 0.402 q2. Similarly, and you're going to retain this q2 0.201 q2. Now multiply this with here. So upon adding this, you will get 4.201 q2. Upon adding this, you're getting 1.402 q2, and this one. Now if you are trying to do the matrix multiplication, 4.201 q2 into q2 is q2 square plus 1.402 q2 into 0.20. 1.402 into 0.20, you're going to get 0.2818. q2 into q2 is q2 square equal to 1. So upon adding this, you're going to take q2 square common. Adding 4.201 and 0.281, you're going to get some answer. You're going to get 0.472 as the answer. So you're going to get some answer, and 1 divided by this number, square root of that, all that. I'll just show you over here. q2 is nothing but going to be square root of 1 divided by 4.4828. So if you just put it in the calculator, you will get the value of Q2 like this, and Q2, and substituting Q2 value in this 0.201 into that, you are going to get Q3 value as well. So 0.472 and 0.0948 transpose. So already we have got the zero, like x1 value to be 0 0.5 and 0 minus 0.5. Let me just try to put it in the form of a mode shape. So this is node number 1, node number 2, node number 3. So this one you are going to consider node number 2 and 3 only, because node number 1, the displacements we are considering it as 0. So at node number 2 it is 0.5 at some number, at some distance from the positive axis, put it 0.5. For minus 0.5 at some distance in the negative direction, put it minus 0.5. Join this first and this one, and from here to here and back to this original axis, the origin axis. Similarly, if you're doing it for the second mode shape, you're getting the values as 0.472 and 0.0948. So 0.472 is a bigger number, so you're going to put it at a bigger height, and 0.0948 is a smaller number than this, so you're going to put it at smaller height. You're going to join all these three, you're just going to get the mode shape. So this is how you're going to solve the problem. I hope you have understood this. As I told, there are some slight mistakes over here, because I having forgotten that x, and that is a big problem. So please take that into account and try to solve the problem. Thank you.